Let's see if I can do this. Uh, we're gonna wait till 6 o'clock. Sorry? Oh, yeah. Okay, it's okay. Yeah, the next part here is structure. Um, so what you'll notice is that each of these components is ordered in a specific manner, and if you refresh the page, that order will not change, right? And each component kind of has its own, I guess, specific expected behavior. So, for example, we're expecting this to be larger than this. So generally what you'll see is that each of these kind of components or tags, depending on the specific language framework you're using, um, has like a specific location that you give it with the structure. Um, and generally this is done with HTML or some variant of it. And we'll get into what that looks like with our React site that we worked with last time. Okay. And then the last part is some sort of logic. So with our basic site that we had a button where if you clicked it, it would increase the count. Um, so this is just persisted only on your own kind of web browser. Because if you refresh the page or close the browser and reopen it, that number will be lost forever. Right. So that's what it means to be client side. Essentially, all the logic is happening on your own machine. So if you like terminate it, that whatever values you had don't persist. Okay, and this is typically done with JavaScript. Okay, so kind of a quick summary of what we just did. Um, some people like this analogy where like you have a car. I guess the HTML is like the structure part, the frame. CSS is the color, and then JavaScript is like the actual engine that allows you to draw. And then on the right, I have some small code samples of what each of those looks like. On the top is HTML, CSS, and then JavaScript at the bottom. Okay, any questions on like at a high level how these three interact, why they're required? Okay, cool. Then let's get into React, which is what we've been using to create our website, what we used last time. So yeah, React is basically what's known as a JavaScript library. So a library, if you're unfamiliar, is just a collection of other people's code. So we use this because we don't have to go and actually create everything from scratch, right? So it was created by Facebook, um, and it uses a syntax called JSX, which essentially allows us to write JavaScript code, but with like the syntax of HTML. And this just allows the code to look cleaner, easier to read, and easier to edit. Okay, so I'm not going to get into all the details, but if you want to know more about like how to actually code a React site, this link here should give you some of the ACM Hacks past workshops. Any questions on what React is at a high level? Okay. So before we actually get into some of the key specific features that we're going to be using with React, let me quickly switch over and show you the React site that we built last time. So this again is just in that same ACM Cloud repo that you should all have access to. It's also linked on the bottom of the slides there. Okay. Is this too small, or can you guys see it? Okay. I'll leave it for now, but let me know if it's too small. So let me go ahead and open up this a little bigger. Okay. You should just, oh, there we go. Okay. Yep, it makes sense this too. We don't need it. Okay, so I've gone ahead and opened up this app.jsx file. This is the file that's basically contains the whole site. Um, so if we scroll through here, we can see the bulk of it has some sort of HTML code there, right? And uh, what's it? So over here it has that v plus React, and then count is, and then some sort of something's happening here, right? And then some more text here. So this is essentially how we give our site the structure with HTML. And then for CSS, the styling, if we look at the index.css file, you can see, for example, here, this A tag is highlighted with this particular color and this particular font weight. We don't have to get into all the specifics, but generally at a high level, this is how you would do the styling. And then finally, we see that this line here is doing something. We'll get into the specifics in a second, but we can see that it's managing some sort of count. Again, it's tied to this like clicking count in some sort of way. So that's the logic, the JavaScript part. Okay, cool. So let's go back to the slides and talk about the fundamental kind of building blocks of a React site, namely components. So yeah, essentially every site can be divided into individual parts, like as you saw with the HTML. So in order to keep our code clean, we generally divide this up into components. So for example, maybe we want to display somewhere this is a component, and we want to have it displayed like 50 times in our website. It doesn't really make sense to clutter up our main app.jsx file with a bunch of these paragraph tags. Instead, we can make a specific component and then just render this component 50 times. So in this case, we're just rendering it once. But the key here is that this isn't a separate file, and we define it as a function. And then what's being returned here is essentially the content that's rendered by that component. So in this case, just one paragraph tag. And then at the end here, we're just exporting this component function so that other files can import it and use it. So here we're importing it, and then we're rendering it using kind of the JSX, like HTML-like syntax. Okay. Another thing that you'll see, not in this example, is that you can pass parameters to components. So for example, maybe you want to render this is, and then some sort of like customizable string. You can pass in a parameter here, and then render your parameter in the body. And to do that, you need to use curly braces within the JSX. So if we go back to the site, you'll see that for count, we're saying count is, and then curly braces here, right? So this isn't being passed in as a parameter, but it's that same format where a variable is being passed in and rendered in the actual JSX components. Okay. Any questions on what a component is or the basics? Okay. Let's move forward then. So another thing you'll see is this notion of state. So the way that React works is that it looks at your code, looks at those return statements and renders everything once. And then it tries to behave lazily. So it doesn't really monitor anything, like render it like over and over again. So let's just say you want to have something dynamic on your site. You need to tell React, like, hey, keep an eye on this so that I know when to attempt to re-render. So that's kind of where the state hook comes into play. So React has this thing called useState. You can see we're importing it up there. Where basically, if you use that hook, you're telling the React site, keep an eye on this variable. So if it changes, re-render the site, or re-render the components that depend on it. So the way that it works is that we, like for count, for example, we have a function to update it, and we have a variable to reference it. So just ignoring this top part and looking down here, we can see we have a button tag, and then when it's clicked, we're setting the count equal to the current count plus 1. So that's kind of the logic behind how that button actually works, right? If you click it, it basically adds 1 to the current count and then updates the count. To actually declare this set count and count variable, you have to use this specific syntax here. Where basically you declare this const and then use square brackets to clear the variable name and then the function. The general convention is to use like lowercase starting letters and then just have this be the same thing as that, just with set at the front. And then finally on the right, when we're saying equals use state, we give it the initial value, which in this case is just 0. Does that make sense to everyone, how the state stuff works? Okay, awesome. Okay, and then another part of the site, this wasn't showcased in the simple site that we looked at, but it will be in the demo that you'll be working with later today, is routing. So whenever you go to a website, generally there are multiple pages, right? It's not just one simple kind of stupid page like we've been working with. So what you'll need to do is have some sort of way to switch between those pages. So generally what I use and what people use is this thing called React Router. It's like another library that we can import. And what it lets you do is declare particular routes that have these subdomains here, so like slash whatever, and then a component that should be rendered if we're at that subdomain. So for example, if we go to localhost 3000 slash signup, it should render this signup component. If we go to localhost 3000 slash home, it should render this home component. And then you can also use like a link component, which basically acts like a button, or like an A tag if you're familiar, where if you click on it, it will route to a different path. Okay. Does that make sense generally at a high level how that works? So now we'll take a quick look at the site that you guys are going to be working with later today. So again, the same repo. This is just under week 4 instead of week 3. Let me open that up. So I'll go ahead and run it quickly. Terminal. Okay, new terminal. And then to run it, it's the same command as last time, npm. Well, I need to go into the week 4 folder and then run npm run dev, I believe. And then assuming I have all the dependencies installed, it should run. Damn, that's slow. Okay. So let's open this up. I just held Control and clicked on the link. You could also just copy paste it. Same thing. Okay. But what you'll see is that this site, already you may notice that it has that slash home at the top. Because we actually assigned the slash home subdomain to be the default one. But if I were to go and type in login, press enter, it will route to a different page, right? So it's just rendering a different component. And the same thing could happen if I clicked on this login button. That has a link component attached to it. So when I click on it, it will route to slash login. Okay. I think beyond that, we can just quickly look at the code just to show you like how some of those features are being used. So we can see we have routing, just like we had in that example. If we want to look at what's actually on the homepage, one quick way to do it if you're using VS Code is just to right click this and click go to definition. You can also look under pages because that's where the homepage would be defined. So let's just do that. And we can see, so we're doing our imports. We have some sort of data structure here. It looks like it's an array of individual questions, FAQ questions. So basically that's what's going to be rendered under the frequently asked questions section. And then if we scroll down, we can see we just have some simple HTML. We're rendering here the name of the site, some of the content in that hero section, and then the frequently asked questions at the bottom. And here we're rendering another component. This corresponds to this accordion down here. So if we like expand this, right, we can kind of read what it says. Okay, and then the last thing that I'll say is that you can see that we have all these flash tags here, or I guess props on the tags. So I think it's under this file here. Yeah, so if we look under the app.css file, we can see basically by using this dot and then the name, we can access that and then assign attributes to it so that the site still has some style. Okay, so I think that covers most of the basics that I wanted to touch upon. Does this make sense to everyone? Does anyone have any questions on like why something looks the way it looks or anything like that? Okay, great. So let's move on. You guys will all have some time later to actually work with that, look at the site, run it, and then actually try to deploy it. Okay, so I'll pass it back to Daniel.
So let's say we're running our server on your rinky-dink little laptop, and you get 1 million requests per second. This is pretty much what's going to happen. Like your laptop just cannot handle that amount of traffic. So either your website crashes or your computer crashes and never turns on again. So we'll go over two different types of scaling. So one thing you can do is just increase the processing power of your laptop. You upgrade its GPU, you upgrade its CPU, its RAM, everything, and make it more beefy. Another thing you can do is just add more servers, right? So you just increase the number of nodes instead of increasing the power of each node. And that's called horizontal scaling. And so we'll go over the pros and cons of these two approaches. So yeah, vertical is increasing the capacity of each server. And the downside of this is that while you're running your site or whatever sort of infrastructure on this server, it requires a lot of time to actually like physically upgrade it, right? So while you're doing that, you can't really use this server. And so if you're a business, this is going to be a nightmare since it's like the longer it takes to upgrade all your servers, the less money you'll make, and the cost to that. In addition, there's limits on scaling, just like based on physics, right? It's like all your components generate a lot of heat, so like cooling that is going to be a nightmare once you get big enough. Also, there's probably going to be some latency from the network. So like if I'm trying to access a server in China, it doesn't matter how powerful that server in China is going to be. The time it takes for my request to get to the Chinese server, it's gonna that latency just cannot be shortened unless you like replace the entire network infrastructure. In addition, but the pros of this is that your code can basically stay the same, right? Your system architecture can stay the same. So from that end, you're like basically trading off, the like upgrading the infrastructure with like the complexity of having to rewrite your entire code base. To contrast with that, horizontal scaling increases the number of servers. And so the advantage of this is you get fault tolerance in addition to backup instances. So if a couple servers fail, you have other servers that can take on some of that load, right? Whereas if you have vertical scaling, you don't really have that increased reliability. In addition, the limits to scaling horizontally is much higher than scaling vertically. So you can pretty much add like an infinite number of servers for like like a practically infinite number. Um, and the downside of this is that you usually have to change your system architecture. So you have to have a way to like manage all of those server nodes and like distribute traffic and all that between the instances. And in addition, it's usually much more difficult to write the good software that can utilize all of these horizontal instances, rather than just keeping a simple architecture but just increasing the capability of each node. And so one really important concept for this is load balancing. So let's just say you have two servers, right? How exactly do you distribute load between them? Well, if you picture a server capacity as like pouring water into a cup, one thing you can do is like pour water into one cup, and then like when it fills up, you pour into the other. So the analogy would basically be like, yeah, just send all the traffic to one server, and once that's like reaching capacity, you send to the other server. But yeah, there's like the issue with throttling if you do that. So like it would be generally a much better way to do this is to keep the load like evenly distributed across all your server instances. And that's the job of this component right here, the load balancer. And so what is load balancing? Well, it's basically just in the name, balancing the network traffic load between all your servers. And so there's different ways to accomplish this. One way is like a static method where it's just you have a set algorithm and you're distributing it across all your connections. Another way is a dynamic method where we're actually gathering data from each node and then deciding what to do based on the current state of your nodes. And so you can also target different parts of the network stack. So layer 4 load balancer would target the TCP/UDP protocol versus layer 7, which is much more common these days. This is going to target HTTPS or DNS. It's gonna extract the network information from that, or like change your DNS server. Cloudflare has a service for this. Yeah, that like layer 7 is generally the most common these days. Layer 4 is like considered kind of outdated, and it's like very limited in use. And so we're, one way a DNS balancer gives accomplishes this is it basically just gives different server IPs to the client. So whenever you make a DNS request, that means you're resolving your website the URL into an actual IP address. It's basically just going to distribute different server IPs depending on who the client is. It can be like a round robin thing or like decide based on your location. You can also have an Anycast IP applied to your servers. So basically just have one single point of contact, and then yeah, the servers in your private network are going to be hidden away from the public network. So you're basically mapping one single IP to many different physical machines. And the advantage of this is that you get more security. You can basically just hide the internal network, this architecture from the outside. So hackers will have a much more difficult time finding the IP addresses to hack in your internal server. And so yeah, these are just kind of the most common methods. So you have like a round robin where you just go around in a circle and just repeat that forever. You can use an IP hash where you basically just grab the IP address, run a hash function, and then like do a modulo operation to decide which server you're sending your data to. This is a dynamic load balancing method. So you basically just have to keep polling each server for to see how many connections you have, and then you just choose one of these connections. Yeah, the rest of these are also dynamic load balancing methods. And yeah.
Cool, yeah. So now that we know a little bit about load balancing, let's actually apply it with AWS. So to kind of motivate it a little more, let's kind of think back to our example that we had last. We had a simple React site running on an Amazon EC2 virtual machine, and then we had a single user, just us, kind of trying to access it. Okay? But what you'll note is that our endpoint was technically publicly accessible, right? Like if we wanted to, we could create our own company and actually have that as our website and have people access it. So let's just say that now we have many people trying to access our website. What do you think may happen? Yeah, go ahead. Thank you. Yeah, exactly. Yeah, we'll probably end up with some sort of issue, right? We're not going to be able to handle all the requests. So how might we be able to address that? Daniel brought up a couple good points. A second. Yeah, go ahead. Yeah, exactly. So one way to do it would be to just have multiple instances like this. And then I know this diagram, it looks like they can access any of them, but we want to have some sort of single point of contact here where we can balance between the three. Why might we not want to do like vertical scaling? Why might we not want like one really large EC2 instance? Yeah, go ahead, Tim. Yeah, that's a good point. It's like a single point of failure. Um, I think the reason that I would give is because is it on there? Oh, okay, it's right there. The requests are relatively simple. Like in our case, our website is just like it's basically just like a text file, right? More or less, or a couple text files. So we don't really need complex hardware to like serve those requests. The problem is that we're getting too many requests. So even if you have a larger instance, it may be able to handle more requests, but probably not proportionally compared to if you had like multiple different instances. And then in addition to that, the single point of failure thing is great. And then with this, you can also distribute them globally so that different customers can have like shorter load times, right? If they're trying to access your site. Okay. But yeah, so with this model, just assuming we have three individual EC2 instances, there are still problems. Namely, let's just say we want to do an update, right? We want to add a second button, maybe. We're going to have to go and roll out those changes to each of these EC2 instances. And ideally, we'd want to do it all at once, right? But ideally, even better, we could have just a single change that we could make, and it would automatically change. And then for routing, under this model, we would have to have an individual IP address here for each EC2 instance. So ideally, we can have all the users access one like URL, and then it would automatically kind of route them to the correct IP address, depending on either the location or any of the other load balancing methods Daniel mentioned. Okay, so before we talk about Elastic Beanstalk, um, just to kind of motivate why EC2 is still pretty useful, it does give us instance level configuration, meaning we can configure a lot about the actual virtual machine that we're working with, namely like the operating system, the memory, the CPU. So we can configure it to like a specific use case. But when we want to manage multiple EC2 instances, generally EC2 is not going to be enough for us. We're going to want to use either another service or some other tool to do it. Okay, so that brings us to Elastic Beanstalk. So Elastic Beanstalk is essentially a platform as a service tool or a managed service, if you remember from our first workshop. And what that really means is that it itself doesn't have any resources. It's just using EC2 resources under the hood and a couple other resources. But it gives us a very simple kind of user-friendly interface to kind of configure multiple EC2 instances and run code. Yeah, and another great thing about Elastic Beanstalk is that most of the configuration can be like automatically handled for you. So let's just say you have a piece of code that you want to run, like we do in our case, right? We have our website. We don't actually have to go in and do all that like proxy configuration that we had to do last time. We can actually just upload the code directly and have it take care of it for us. Okay, so in our case, although Elastic Beanstalk does let you just directly deploy like a Node.js React site to like just by uploading the code, we're actually going to be using Docker just to teach you guys how that works, and because in future parts we're going to be using Docker as well. But here are a couple other frameworks that they support directly kind of uploading codes to Python, Java, whatever. Yeah, and then some other features of Elastic Beanstalk are scaling, which we haven't really talked about, but essentially, let's just say these three instances are not enough to serve all the requests. It can automatically provision like another couple instances, and then when demand is low, it can get rid of those additional instances. So that's called auto scaling. And then load balancing, obviously, like we talked about. And then you can also configure this to automatically log like the health of the instances, periodically run health checks, that kind of thing. And then it also can work with like AWS database services. We're not going to be using them here, but it is a feature that they support. Okay, any questions on Elastic Beanstalk like features? Okay, great. So then let's get into how to use Docker. Um, okay, so what exactly is Docker? Maybe some of you have heard about it. Maybe some of you have worked with it. But yeah, Docker is essentially just like a developer tool for bundling together an application. So for example, we have our website, right? We want all the dependencies and everything to just be kind of together in one place so that we can just share that place somewhere else, and then people can just run their site, regardless of the operating system that they're working with or anything like that. So yeah, once they actually kind of deploy or bundle together stuff, that's called a container. And the bundled together stuff is called an image. Yeah, so the real advantage of containers are that they can run on any host regardless of the operating system, assuming they have this thing called the Docker daemon running on their computer. So what that kind of looks like here from an architecture perspective is that on the right we have Docker, and then on the left here we have our virtual machine, kind of what we were doing with EC2. So here we can be running any operating system, and assuming we're running the Docker daemon, which is the container engine, we can run our containers, and they'll essentially just go through the container engine and then leverage the underlying operating system. With a virtual machine, by contrast, this is more kind of like an abstraction provided by the hardware, where there may be an operating system under here, but there's this thing called a hypervisor that basically lets us use any operating system above it, and then it translates it to the underlying infrastructure that's used by the physical hardware that's running the virtual machine. So does that make sense? Kind of what the distinction there is? From a developer perspective, you'd want to containerize your applications or use like Docker or an alternative because it allows your code to be a lot more portable. So you can run it with AWS, you can run it with Google Cloud, you can run it on your own computer and your friend's computer that has a Mac or Linux machine or whatever, without having to worry about any of that. Does that make sense to everyone? Okay, and then the last thing is from a hardware perspective, you want to, or you may want to have a hypervisor. Like Amazon would want to have a hypervisor so they can support code that only runs on a Windows machine or only runs on a Linux machine. Okay, so getting a little bit more into the terminology, like I mentioned before, an image is just your kind of bundled up code. So everything that you need to run your application is in the image. Generally, this will just be like a set of references to other like dependencies and stuff that are publicly accessible. So it won't actually be like a super large file, but it's basically like a document of everything you need so that you can build a container or build and run a container, I should say. So a container is just a running image. So once you get an image, build it, you can run your container. Run it as a container. And then beyond that, there's this thing called Docker Hub. So this is kind of like GitHub, but essentially just for images instead of for code. And it's what's known as a container registry. Amazon has their own proprietary one that we'll be using later on, not this week. But yeah, for now, we'll just stick with Docker Hub. And then there's this thing called Docker Desktop. This is basically just like a UI user interface for the Docker daemon. So theoretically, you could start the Docker daemon through the command line and interact with it only with the command line. And we'll be doing that a little bit, but you can also use Docker Desktop if you like clicking buttons and seeing it visually. Okay. Any questions on these four? This is like the basics that you'll need to know. Okay. So then let's do a little bit of a demo here where we just kind of show off the basics of using Docker. So just some prerequisites. You'll need a Docker account. So you can create it by going to that link. And then you'll probably want to download Docker Desktop for your operating system, which you can also find at that link. But assuming that's already been taken care of, we will want to run this command here, which will basically just confirm everything is installed properly. So I'm going to go back to my VS Code window and open up a terminal again. Looks like it's opening a new one, so I'll just trash these opens. And then just paste that command in with right click. And then if I press enter, okay, if I press enter, it says that error to connect, right? This may indicate that the Docker daemon is not running. So the Docker daemon isn't, I think I disabled it. By default, it may be like, it may start up as a startup program or whatever, but I think I disabled it. So I'm just going to click on Docker Desktop here, we'll search, open that up. And this will automatically start the Docker daemon. Like I said, you can do it through the command line if you want, but so let's give this a second to open up. Okay, it's starting. This normally does not take too long, so another 10 seconds or so. Oh. Any questions on what we've, oh, okay, there we go. But any questions on like what we've done so far? Which isn't really much. Okay, so yeah, once you open Docker, I guess the next step is just to paste this in. And we can see it should say, hello from Docker. This message shows that your installation is working correctly. So now we can actually try to use an image. So what you'll want to do is go ahead and run this command here. So just kind of like GitHub, this will, I guess a way to describe it is that it's cloning or pulling down a container called BusyBox from Docker Desktop. So if I paste that in, let me move this at the bottom, we can see, just enter. You can see, so it's going to try to download all the necessary parts of that image. And it just finished. So now that we have this image, let's actually try to run it, or before we do actually, we can run this command. Let me change this to say image because we actually haven't run anything yet. Oh, damn, that's a lot. Okay. Hold on a second. I gotta clean this up later, but it should be somewhere here. There we go. So we can see we do have this image, right? BusyBox, and then I don't know why it says 2 weeks ago. Maybe it shouldn't say 2 weeks ago for you. Just ignore that for now. Maybe I already had the latest version or something. Okay, so let's change that. Okay, beyond that though, now that we have the image, it's actually running. So I'm gonna go ahead and copy this command, and then we'll look at what it will do. Okay, so we can see that it printed out hello from BusyBox. So what is this command actually doing though? So if we read it, right, saying Docker run, and then we're providing the image to use, BusyBox. Then everything after is what we're plugging into the container. So we're basically saying run this container with these parameters. And then these parameters just are just some Linux commands that it can run on the container. So it's just saying echo, essentially print out, and then this string. So we can see it did that, and then it killed the container. So now I have a command. Sometimes when you run a container that, for example, like has a website, it may not kill the container at the end because it's still hosting the website. So you just want to keep that in mind. If you don't see this command line at the bottom, it's still running. Okay, any questions on how we just did that or what's really happening? Okay, let's move forward then. Or actually, we can do this. Yeah, no, we'll wrap it up there. Okay, so before we move forward, any questions on the front end stuff that we talked about, what Elastic Beanstalk is, or how to use Docker? Okay, then what we will do is we will turn it over to you guys. So that's the link to the current week's kind of project. If we open it up, we can see there should be a README at the bottom that has a step-by-step guide on how to deploy our new website, the Facebook one, with Elastic Beanstalk. So what you'll be doing is creating a Docker image with it, and then deploying that Docker image using Elastic Beanstalk. So yeah, we'll probably reconvene maybe around 7:30 or so. So take some time to try to follow these steps. Make sure that you have a Docker account, an Amazon account, and we will kind of be circulating around the interns and us to help out. Oh yeah, do you want to do it now? Or... Also, we're going to have a social tomorrow from 5 to 6 in Saxon, I believe. So
It's like walking.
no, we don't have to book it. Yeah. So yeah, if you can make it, feel free to show up. We'll have cookies, I believe, right?
Yeah.
Free cookies.
Wait, did I have some preferences?
Get the projector a second. Okay, what? Wait, why is this not working? There we go. Okay, it's working now. Okay, sorry about that. Everything's good now, though. Okay, how far did people get? Just out of curiosity. Uh, did anyone finish the Dockerizing parts? Okay, cool. Did anyone get to using Elastic Beanstalk or trying to? Okay, nice. Great. Um, did anyone fully deploy it in the process? Okay. So yeah, let's go ahead and I will open up. So this is kind of where I'm expecting folks to start. Right, they have all the files locally, but they haven't run anything. So let's open up a new terminal. And then we will make sure that we're in the correct directory. So we have to switch over to week 4. So week 4, right? And then press enter, change directory. And then here I'm going to start by running. I'm going to skip this first command, Docker version, because we already did it together, more or less. I will run this next command here. So this is going to be Docker build. And then, so what this command is going to do, we're going to have to give it a couple of parameters, but it's going to look at this Docker file, and then it's going to basically run this. This is our actual kind of image outline. So a very high level going through this, it's saying from like version 18 of Node.js, copy the current, or set the working directory to app, and then copy over all the current files into the app working directory. And then it's saying install, like run npm install, run npm run build, and then pull in nginx, which is that reverse proxy that we used last time. And then it's basically doing a little bit of configuration. So let's go ahead and run this build command, which again, it'll just run all these steps. So we have to put it under a user in Docker. So me / ACM cloud a week 4 live, I guess we can call it. And then we have to specify which directory to look at to do this build command. So just dot is the command. Okay, so very clearly did not work. I think we forgot a -t in. Like that. There we go. Okay, so this will take a second because it has to pull in these 2 templates, right? The Node template and the Nginx template. Because I've done it before, it runs a little quickly. So once we're done with that, we can run Docker image ls, and this will print out like, all the images that I have. So I have a bunch of garbage here, but it should be right here, right? You can see it did create the image. Okay, so now that I have the image, let me just run it locally to confirm that the image actually works, right? Because otherwise we're just doing running commands, we don't have anything to know that it's actually working. So if we run Docker run -p to specify the port mapping, and then I'm going to say map port 300 or 3000, sorry, to port 80. So what this is going to do is say, so when you build the site, right, by default, it's hosting it. When I'm running Nginx, by default, it's hosting it on port 80. Just like we saw last week, right? When you deploy that the website with Nginx on EC2, you can go to HTTP, right, and access it. Somebody asked a great question about like if you could change the port. So what we want to say is to run this container, but instead of port 80, like map that to port 3000 on my own machine. And then we just need to specify the actual container. God, what did I call this? Cloud AWS demo before. Okay, so we can see it does not give me a new kind of command line here, right? It's still running. So now if we go to my browser and then open up localhost 3000, because that's the port that I mapped to, we can see this container is running now, right? So we are using the Docker to run this site instead of running it locally, like I guess on our own machine, so to speak. Okay, so now how do we stop this from running, right? I don't want the site to continue running forever. Well, to do that, I can open another terminal either by clicking plus here or new terminal again, and then run Docker container ls. So this will print out all the running containers. So what I want to do then is Docker stop, what's it, Docker container stop or something, and then the container ID. D135 90 317 today. Okay, so I went ahead and stopped it. So if I run this command again, we can see there's nothing running. And if I go back to the original terminal, we can see it stopped running. Okay, so that's the Docker bit squared away. We were able to containerize our application. Does that make sense to everyone? Kind of what we did? Okay, so let's move on to Elastic Beanstalk, the actual AWS stuff. I'm just going to go look up AWS console. And then I guess we can just go here and then sign into console. Okay, it looks like I already signed in at some point, so it saved my session, but you would just have to log in. Okay, the next step is to create an IAM role. So this is the reason why we need to do this is because we want our Elastic Beanstalk to be able to access Docker and run it with Docker, run a site with Docker. So to do that, you can just search up IAM up here and then move this and then click on IAM. And then you'll want to click on roles on the left. And then you just want to click create role up here to create a new role. And just like we talked about last time, you have to just give it specific policies, right? That tell whoever has the role, hey, you can access this, or hey, you cannot access this. So we're gonna leave this as AWS service, and then select Elastic Beanstalk, I believe, because that's the principal that's going to be actually using the role. Hold on, let's see. Sorry, we need to click EC2. That's my bad. Give me 1 second. Remove this. The reason why we want to select EC2 is because the underlying EC2 instances are what need to access the Docker container, not necessarily Elastic Beanstalk. Elastic Beanstalk just manages the EC2 instances. But yeah, it can be a bit tricky there. Okay, so next, selected EC2, and now we just need to select those three permissions. So I'm just going to search. And then if it has this little icon here, that means it's an AWS managed policy. So we can't edit this. This is given to us by AWS. So we just check that box. We can close this. Not that. Copy this. And then just repeat the process for all three. Okay. Okay, not great. There we go. Must have misspelled something. Okay, so now once we close this, we should see and click next. There should be 3 permissions selected. And we're good to go. So create role. Oh, actually, we have to give it a name. AWS demo week 4 live. You can call it whatever you want. Okay, create role. We can see it was created. Okay, so now that we have that logistics stuff out of the way, let's actually work with Elastic Beanstalk. So now we want to look up Elastic Beanstalk. Click on that. The console here looks a little bit weird. So let's click on create application. Okay. So what we're going to want to do is leave it as web server environment because we're hosting a website. We can give it a name, ACM Cloud Week 4 Live. And then we can theoretically here you can give it if you want like to prefix your URL or something, you can do it. I don't really care, so we'll just leave it normal. And then here we can select which platform we want our code to be. So like I mentioned before, they do have this option of Node.js, which will allow you to just directly upload your code. But because later on we want to kind of automate the process of deploying code, we're going to be using Docker. And it's just a good skill to kind of know how to use Docker. And then we can leave these settings as they are. And then here, we want to switch this to upload your code. So this is going to let us upload a file that will indicate to use that Docker image that we just created. So here we can just give it any version label and then local file, and we need to upload a file. So choose file. I'm going to go under, where is this? Cloud. Here. So I'm just going to that same, this is my same directory that has all the project files in it. And this Docker run AWS file is the one that I want to upload. But before I do that, let's look at what's actually in that file. So what we can see here is that it's basically saying what the version should be, and then telling us which image to use, and then some port mapping here, and then a bit about log, which isn't too important. So the key part to recognize is that up here, I am using a Docker image that's under my Docker Hub account with this particular name. So if I wanted to, I could change this name to be the one that I just created live with you guys, right? Because this is one that I created a while ago, like just to make sure that everything was working. I think the one that I just created was like it had a live at the end or something. But for the purposes of this demo, I'll just keep it the way it is. So I'll just select the file and then scroll down, and we can leave that as it is. Okay, so before I go on, any questions so far? What we've done or why we did it, where we did? Okay, so I'm pressing next. Okay, so here I need to select, if you want to connect to your EC2 instance with SSH, this is where you provide those credentials. We don't really need to worry about it, so we'll just leave it the way it is. Well, actually, we have to select, yeah, we'll just leave it. And then here is where you basically give it permissions for what the EC2 instance has access to. So you want the EC2 instances to have access to Docker, which is why we're giving it the permission we just created. Okay, I think we can skip to review. Let me check. Yes. So let's just go ahead and do that. But if we wanted to, we also have the ability to configure like all these other details, including the scaling, which we'll get to in a second. Okay, so we can review this and then just click submit. Okay, so normally this takes a second or two. So let's just let it load. I will say that I think I didn't mention this command here when we were going through the Docker stuff, so I'll just do it briefly now. When we created the image together, I just created it locally on my own computer, but I didn't actually push it out to Docker Hub. So you have to run this command to actually like push it out to Docker Hub so that AWS can pull it in. If you want to use your own. So assuming you update that this file here to use your own container name, you'd have to push it out. Great. Let's give that a second. Actually, while this is loading, let's talk about how the load balancing works for this. So if we click on configuration here, there should be a section here on instance traffic and scaling. So let's click edit. And we can see that if we scroll down enough, there's this thing called an auto scaling group. Where right now the environment type is just a single instance. But we could change this to load balanced and then indicate a minimum and maximum number of instances that we want. And then we can also choose the instance type. So this isn't super critical, but spot instances are instances that will provision when the price is low enough, essentially. And on-demand instances are just instances that you're buying whenever, like full price, I guess. Yeah, but this is not under the free tip, which is why we didn't do it. But this is where you would configure it if you wanted to. Okay, so we can cancel this and go back to here. Okay, it looks like it's still launching. So yeah, what's up? No, not exactly. You can run multiple EC2 instances. I forget exactly. Like it'd be on the EC2 pricing website. Yeah, I think you have a certain number of hours that you can run. So you could theoretically run like 10. I think it's 750 hours with like one or two different EC2 types, instance types. Yeah.
So we only have like one instance. I mean, like Elastic Stock basically.
Good question. Well, keep in mind, we didn't have to go in and configure any of the Nginx stuff because it's all in the Docker container. So if you want to deploy a Docker container very like in a kind of managed fashion, right, you could do it this way.
So Docker.
I agree. Yeah, it's more because of Docker, but if let's just say you want to deploy a Docker container with EC2, right? That's not really practical. I mean, you can install Docker and then do it, but it's like more overhead, right? You have to go in and do it. There are other tools that also support like running containers that we'll see. So, okay, I don't know why this is taking so long. Oh dear. Okay, so it looks like it failed. Okay. Why did it fail? So let's click on logs here and see if we can see. Nothing here. Okay, let's go to the domain and just see if it's working. I don't think it is. It looks like it failed. Um, but okay. So something is probably either wrong with the file that we uploaded. That's a good idea. What we can check is so I'm going to create a new terminal here and try to pull down this Docker container to see if it really is on Docker Hub. So I can run Docker pull. Okay, maybe I deleted that or something. So let's give that a shot. Let's see. So if I change the name here, AWS demo. Right, what did I call it? Okay, I'm gonna run the build command one more time. I'm not in the right directory, that's why. Okay, yeah, we'll use our own image that we just created. So let me build it, and then push it out. Docker push. That's not the right one. There we go. This one. Okay, sometimes the push takes a while, but once it's done, you'll not only will you see it in the command line, you should also be able to go here and I think on Hub, yeah, if you click Hub here, you can see uh the active uh images that you have on your Docker Hub. It looks like I may have changed the name from week 2 to week 4. That's probably what it is. It's just kind of dumb. But yeah, let's try to refresh this. Okay, we can see we have 2 pages. This one's here. So now ACM Cloud 5. There we go. Okay, saving that. And then uh this should be right. Okay. Let's look if we can check here. Yeah. Yeah. Okay. So let's just say it fails, right? Like this is pretty common. How can we like do we have to start from scratch? The answer is no. We can maybe it's no. Actually, hold on. There should be a way to oh, okay. In this case, we are gonna have to start from scratch because we changed the name. But normally you can click rebuild environment here if you're using the same Docker image. So if I pushed it out, actually let's do that. Um we want to do that. No, that so theoretically I could rebuild the image with the correct name and push it out, right? And then rebuild this. But because we've already gone through the process, let's just create a new application and I'll delete this old one later. 5, 3, 4, 2. Okay. Okay. So in this case, when I created the application, it did not create the environment together. So I'm creating the environment under that application right now. Last time I did it in one step. Upload your code. Boom. Okay, we can leave this default and then live again. Skip to review. Okay, submit. So while this is provisioning, I'll just take a moment to say, make sure that once you do these things to delete your resources afterwards. The free tier is pretty liberal, but if you leave this for like a couple months or something, they'll probably start charging you like $10 a month or less than that or whatever. So obviously that's not ideal. So yeah, just keep that in mind. Yep. So I'll just show you what it looks like for this one. Let me make sure this is the right one first. Okay, this is the new one. Okay. So if we go into applications, this is the old one, right? The one that's not working. It has errors. So we can click on actions here, terminate environment. And then like that. Okay, terminate. So now this one should be good. Not with the way that it is right now, but once we get to week 8, you'll just have to run one command and everything. So yeah, even the backend, which we haven't even got to. Okay. Yeah, this unfortunately sometimes takes some time, so we will. Any questions though on anything so far? Just hope to God I spelled this right. Yeah, what's up?
When I deployed my site,
Mhm.
it already has like the users that you guys created.
Yes,
But those are not like linked, right? Like that is just on my site. It's not linked to the original.
correct. Yeah, so what you'll see is if you look at the files, we can do it while we're waiting. Under profiles here, we have a very simple kind of pseudo database. So this is just like a dictionary, I guess, of user IDs, which is just the username. And then correct. So if you add a user, which you can do through the site, it'll add it to this list. But if you then refresh your page, that won't be persisted anymore, right? Because it's just on your client side logic. So what we want to do is find a way to persist this information with like some external database that's always running, so that we can just ping it and get all the users when we need to, instead of having it all on the client side. Yeah. Okay, thank God. It says successful. So let's open this up. Yay, we can see it's working. Okay, cool. So I guess going full circle, I think that essentially wraps up what we have. Yeah, next time we will be talking about like DevOps and CI/CD. So we'll be kind of automating this process so you can deploy it with just like a simple commit to the repo. Like if you make a change, it'll kind of propagate that change all the way to the live site. But yeah, feel free to stick around if you have any questions. We have a social tomorrow, 5 to 6. Try to be there if you can. Cookies. Other than that, I guess have a great rest of your night.